Steam Coin Challenge. In this challenge, we are dealing with a cryptocurrency provider set in a steampunk kind of vibe. We can do things such as create an account, log into our account, and then manage our Steam Coin wallet. We also notice a settings page, and this page allows us to upload identification documents. As you can see, this kind of mimics a very common type of new crypto exchanges popping up left, right, and center. But luckily, this challenge has limited functionality, which means that we don't get stuck in as many rabbit holes. Furthermore, we even get the source code of this challenge, and that is a game changer because we don't need to spray and pray the website with payloads. We can actually look at what the target is doing, craft payloads locally, and then execute them on the remote knowing they worked locally. Now let's start by looking at the infrastructure of this challenge, and it is fairly simple. We are communicating with a reverse proxy, and that reverse proxy is forwarding our requests to a Node.js application. And that Node.js application is in turn communicating with a CouchDB database. Now that you have an image of how the setup of this challenge looks, let's get into the fun part, the hacking. Alright, let's get into it. And I'm going to start by looking at the code. And in specific, this database.js file, because this database is quite interesting. It uses CouchDB, which is new for me. Like, as you can see, they connect to it using a URL. But in this init function, we also see that it creates a table users, and then it creates the admin user. So the username is admin, the password is random, and then the verification document is the flag. So that is our goal. Our goal is to get the verification document of the admin. So how would you go about getting that? Well, a first quick idea could be to become the admin user. So let's take that as a first goal, become the admin user. But how do we do that? Well, a good first step would be to look at how the ACL, the access controls here, work in this challenge. And for that, we're going to go to the index.js, and this gives us all the endpoints and what happens when you visit an endpoint. For example, if you visit register, you get shown the register.html file. Well, if we go to one that is authenticated, such as the settings, we see that the endpoint just signifies what to do when you get that endpoint. It sends you the settings page. It never checks your authentication here. And that's because all of that is happening in middleware here, the auth middleware. So this is where we want to look if we're talking about access control. Checking our auth middleware file, we see that it is doing a lot here, but all of this has to do with JWT tokens. Now, JWT or JSON Web Tokens are a very common way of doing authentication or access controls on the web. So let's take a closer look at how this works. On the web, I'm going to go into Inspector Tools, and I'm going to check out the storage here. But here you can see that we have a session cookie, and this cookie has a value, a JWT token. But as you can see, it is kind of hard to look at it in this way. It's very long and very strange. Well, luckily there are some tools for us that will base64 decode all of this and give us an easier way to look at it. For example, jwt.io. I've pasted the token here, and here we can see the three parts of the token. In red, we see the header, then we have the payload or the data, and then the signature. For the header, we see that we have an algorithm here. The algorithm here says RS256. We have a type, JWT. We have a key ID, which is the identifier for this key, for the public key being used. Then we have the JKU, and the JKU references a URL, very interesting. And then we have our actual data. And this data is obviously the most interesting part, because here we can see our username is PinkDraconian. So when the server gets a request, it will use the username in this data to see who is logged in. So if I want to be the admin, all I need to have is a token that says my username is admin. But when I do that, you see that the left here gets all empty because it cannot create a token for me. And if you think about it, it I mean, if I were able to just change this and become the admin, then we would have a lot of issues on the web. So that is not possible. And that's all in the design of JDBT tokens. So how does this work? Well, JDBT tokens need to be signed. And this signing is what makes it special. And in this case, we have the algorithm RS256. What does that stand for? Well, R stands for RSA, S stands for SHA, and then 256 is the amount of bits in SHA, so SHA-256. And RSA, if you've dealt with cryptography in the past, you will know is an asymmetric cryptographic algorithm. So it uses a private key and a public key. Now, the private key, only the server has that. So the server has a private key, and using that private key, you can sign tokens. So you can sign the header and payload, get a signature, and make a valid token. That token you can then send across to the user. The user can read this token, but cannot edit it because it's signed, and the signature, the user cannot sign it without the private key. And that's because when you send this token back to the application, the server will verify the token. Using the public key, it will validate it and make sure that that signature is correct. If the signature is not correct, then well, it won't accept that token. Now, how does it actually validate it? Well, it uses a public key, and usually that public key is, well, public. The server has it, and it's just stored on the server somewhere, or it's in an SSL certificate or whatever. But in this case, we are using this JKU value here. And this JKU value is interesting because it has a URL that hosts a JWKS file. And that is a key store. This stores the public keys for this server. So when the server wants to validate a token, it will visit this URL, get the key store, find the key with the right ID from the key ID, and then use that public key to validate the session token. And that's kind of how all of this JDBT stuff works. Now, in this kind of configuration, there is the one really popular exploit that is, I think, the most common and that everybody that has dealt with it will think of in this case, and it's called JWKS spoofing. So how does that work? Well, imagine you're an attacker and you create your own private and public key pair. At this point, obviously, you can sign tokens with your private key pair, but the server won't accept them because the server is using their public key and not your public key. So all the attacker has to do to make their token valid is to make the server think that the public key that the server is using is the attacker's public key. So the server needs to use the attacker's public key, and then the attacker's session token is valid. So what can the attacker do? Well, they change the JKU here to http://attacker.com/jwks.json. Now the server will visit the attacker's domain, get the attacker's public key, and validate using the attacker's public key. And that is how an attacker could perform a JWKS spoofing. And that was my first idea when looking into this challenge. I need to do exactly that, a JWKS spoofing. So I went and looked in the source code to see if that was going to be possible. And in the source code, we can see here that it gets the headers from the JDBT token. It's going to check if the JKU and the key ID header are present. And if that's the case, it's going to do this check. And this check checks for the JKU claim in the header. It checks if it starts with HTTP localhost on port lead. And if not, it's going to send an error, else it's going to actually verify the token. So that is an issue because, well, the scenario I just explained is not possible anymore because we don't control the local host. We don't have a way of putting files on the local host of hosting or malicious JWKS file on the local host. So that kind of breaks everything that I wanted to do. But now that I'm saying it, we have a way of uploading files to the local host, right? If we go to the application, we have this settings page, and on this settings page, we can do things such as upload files. That sounds very interesting, so let's try that out. What happens if I upload a file? So I've just uploaded a file, and I'm gonna open it here, and we can see that my little apple is on the page under the /uploads path. So we have a way of uploading files to the server. Now, obviously, right now I'm uploading an image, which is not really ideal because we want to upload JWKS files, so that has to be a JSON object that, to be fair, I can show. Because we talked here about this JWKS.json file here. I can show the format of that because obviously it is in the source code. So if I scroll down in the index.js file, we see here that the router.get of the JWKS file, it looks like a JSON object that has your keys, which is an array that contains all of your keys. So we are trying to recreate this. Right now we're uploading an image, but we would love to upload something like this. We can look at how this upload functionality works in the source code. And for that, we're going to look at the post request to /API/upload. And here we see a bunch of logic that I'm quickly going to go through. So we should not be the admin, which we are not, so that's fine. We need to actually upload a file, and then we need to pass this function isValidFile. And if that is true, then we're just going to upload the file. So all that's really in our way is this isValidFile function. And scrolling up to it, we see that isValidFile is very simple. If our file name, if the extension of our file name includes any of these, then it is a valid file. So it's only performing a check based on extensions, not based on the actual content type. So what happens if we upload a JSON file, but we just give it the PDF extension? What will happen? Well, I'm going to show you. All right, so I've uploaded a PDF file here, and if I open it in the browser, it is a PDF, or the browser seems to think it's a PDF, but actually it's not a PDF at all, because as you can see, it has 0 pages. What's going on here? Well, let's take a look at the network tab in our inspector tools. I'll reload here, and let's take a look at what the server is actually sending us. And if I look at that, we see that it's JSON. It's an object that has keys. RS256 is the algorithm. It has the E, it has the N. This is my public key that I picked. And this is just accessible like this. Now, okay, I have my public key uploaded here. So what do I need to do? Well, I need to change my token. The username is already admin, and I need to change this JKU to my uploads URL. There we go. And I should send it across to the server like this, and that should hopefully work. That's a pretty lengthy process to do, so this has been automated in a nice way for this challenge. It's always nice to script everything that you are doing. So in this case, I have this getAdminSessionToken file that was part of the write-up, and we can use this. So I've just inputted all of my stuff here, and this is where I create, where the RSA key pair is created. So we're going to generate a key pair. We get the public key, we get the private key, we get the E and the N, which are needed for our JKU data. This is the file that we'll upload. We then have a bunch of functions here, a register function, which just registers, a login function that logs in. We have some more functions here to JWT decode and encode just to make it easier, and then one to upload the document. And this is going to upload our JKU data as JSON as a passport.pdf. So, okay, what is this script actually going to do? It's first of all going to create a new account. It's then going to log in to that new account. It will then take the JWT token, so the cookie, and get the header and the payload. It will then upload our malicious JWKS file to the server. It will get that URL and print that out. And now is where the magic starts. So our header is going to be different. Our header is going to have our JKU, which is that uploads directory or the file that we just uploaded. So our public key file. And then our key ID is just going to be pound in this case, which I've also set in the public key file. Then we also still have to change our username in the payload to be admin, because obviously if our username isn't admin, if we don't actually change the payloads, then why are we even doing this? This was the whole point, right? Now, the most crucial step is we can sign this JWT token using our private key. So we're going to grab the header and the payload and sign it using our private key. And we can do this because we just generated a private key for us, and we know that the server is going to use our public key file. And then we have our session token. and we can start using that. So, okay, let's run that. We see it signs up to an account, it does all the stuff, and it gives us a JWT token at the end for us to use. So let's go into our browser here and sign in to an application the way that it was intended by going into inspect elements and changing the session token directly. And now, if I reload here, we can see that our dashboard has changed. It now says admin panel is under construction, and that is because we are now actually the admin, which is just amazing. One slight issue, and that is that our settings page is also still under construction, and we still cannot get the flag. I mean, we are logged in to the account that has the flag, but we just cannot read it yet. And that is what the next part of this video will be all about. Now that I'm the admin, what is all the cool new stuff that we can do? Well, looking at the bottom of our index.js file, we find this new endpoint, /API/test UI. And this one has this check: if our username is not the admin, we return a 403. So that means that this was not executable by us before. Now that we are the admin, we can actually use this endpoint, and that's amazing. So let's do that. This endpoint uses a path and a keyword which come from the body of this post request, and then it's going to run a UI tester.test UI with that path and keyword. What is this doing? Well, this test UI function is implemented in the bot.js file, and if I go there, then we see that this uses Puppeteer to launch a headless browser. And in that browser, it's going to create a new page. And for that page, it's going to go to HTTP localhost on port lead. And our path is going to be the path we supply. So at this point, we could be controlling something on the server end. This is really interesting because this gives us a lot of opportunities. We can control the file on this website that this browser on the server localhost is going to visit. That is very interesting. Because immediately I get an idea. What if I find an XSS vulnerability on this website? If I find an XSS vulnerability on this website and I send it to this bot, then the bot is going to get exploited by me, which means that I can execute arbitrary JavaScript on the local host. What can my arbitrary JavaScript do? Well, I can make, for example, fetch requests. So I can request more files from the local host. And immediately an interesting one pops to mind. If we head over to the database.js file, we see that this database is accessed via HTTP. And the credentials are even in just here in plain text. So what if I get an XSS on this bot, make it visit this URL and get all of the data out of the database using a fetch request through my XSS in JavaScript? Wouldn't that be incredibly cool? And that is immediately what I want to do. But before we go and find an XSS and try all of that out, let's first of all take a look at this test UI endpoint here, because I haven't yet tried to access it. Let's try to play around with it a little bit to see how it works. So immediately I head over to burp and I'm going to send this request. So what is this request going to do? Well, it's a post request to our test UI endpoint with our admin session code token and a random path and random keyword. And when I send that, I see that I get a 403 forbidden, request forbidden by administrative rules. What in the world is going on here? Like, there's nowhere in that source code of that Node.js server anywhere where this string is referenced. How does this work? Why is this being blocked? And this is where you should get reminded back to that earlier kind of graph we made, where we saw that we are not directly communicating with the Node.js server. No, there is a reverse proxy in between, and that reverse proxy might be doing some shady things. So let's take a look at how that actually works, because we have all of the config files. Here in config, we have the HA proxy config, and it starts with some stuff, the maximum amount of connections, a timeout stuff. We then have our front end HTTP in, which is going to bind to port 80. It's going to have a backend web, and that backend web is specified below here, where we can see that the server it uses is the localhost port lead, which is obviously connecting us to the application. Then it has these ACLs, 2 of them, and the bottom one is the most interesting one. So this is an access control. It's named restricted page, and it's triggered if the path begins with /API/test/UI. Okay, what happens then? Well, it's gonna deny any HTTP request if restricted page is true. So if the path begins with test UI, it's gonna deny that HTTP request, and that is exactly what is blocking us. So we have our whole path that we could start getting into to get the flag, but we can't because the reverse proxy is not allowing this endpoint. Damn, that is quite the bummer. But let's check out how this proxy actually works in the Docker file. So in the Docker file, it's doing a bunch of stuff, and here it's going to install a bunch of things, but also it's going to visit hproxy.org, download 2.4 source 2.4.0. That is the version it's going to download for this reverse proxy. What if there are any public vulnerabilities in this reverse proxy? Well, we can find out with a quick Google, I guess. So we Google for version 2.4.0, are there any CVEs? And some things hop up. So if we open this one, it says HTTP request smuggling, I guess that should be, in HA proxy. I found a blog post detailing it, and this blog post is amazing. Definitely check it out. But this specific vulnerability is an integer overflow that enables HTTP smuggling. Now in Burp, let's take a look at this specific vulnerability. So I have it open right here. And the thing is, we are not allowed to make a post request to API test UI. Right, that is our big blocker. That's what we're not allowed to do. But in this proof of concept here, we see that we make a post request to API/login and then make a post request to API test UI. Why is this allowed? Well, for that, we need to know kind of how this reverse proxy actually works. So this proxy is going to kind of do 2 passes over your request. The first pass is a quick and dirty one. It's just to check if this request should be sent across or not. And that is because this needs to be fast. If you get like a million requests that needs to be dropped, if you're too slow in handling all of them, that's not nice. So this is a fast check. So it's going to go over it, the request. It's going to say, okay, post request to API login, host header is localhost, content length 0 AAAA, whatever's going on here, that's just a header name, that's allowed. Then it's going to say, okay, the real content length is 748. That's all of this. This is all data. This is a post request to API login. That is allowed. Even though here we have API test UI, this is just data of this post request to API login. So that's allowed. So, okay, that checks the first phase, that checks the first pass. It is allowed to be sent across to the backend. But now, well, it needs to be actually sent across to the backend, and that is the second phase. And in this case, it's going to again check, okay, post request to /API/login, cool, host is localhost, and this is where it gets confused. Content length 0 AAA triggers an integer overflow in this reverse proxy, and that causes it to see the content length as 0. What does that mean? Well, that means that this is the request and 0 bytes are the content. So it sends this across to the backend server. And that is the reply that we see here. We see the missing parameters because we don't have the parameters for the login. But then all of this data is still stuck in the buffer of this proxy. And the proxy knows nothing better than to just handle whatever it gets in the buffer. That's how it goes. You make a request, it goes in the buffer, it handles it, sends it to the backend or drops it. But in this case, this is in the buffer, it has already been accepted, it has already passed that check, so it needs to be sent across. And that is why this also gets sent across to the backend and thus executed, and that is how we bypassed that check, making sure that we should not be allowed to make requests to this endpoint. That's all the theory. This works, but we don't get a reply back. So we need to find like a blind way of seeing that we get this request back. But for now, let's assume that this works and let's go and look for that XSS, because remember, if we get an XSS on this endpoint, we can actually do a lot of interesting things. Now, finding an XSS can be quite difficult here because there's not a lot of going on, but you have that upload functionality. That is like a gold mine. Remember what kind of files we could upload? Here we can see we can upload JPEGs, PNGs, SVGs, and PDFs. SVGs are very interesting because they are XML, a markup language. HTML is also a markup language. What would happen if we would just put a script tag like this in an SVG image? So this is the image. It has a nice script tag here. So let's try that out. Let's see if we can upload this, what will happen with the result. So I'm uploading this file, I visit it, and I get an alert. So, okay, that XSS worked, that is great. Now, knowing that we have an XSS, let's make an XSS that pings back to us. So in the back here, I have ngrok on, and I have a listener on port 555. And ngrok is set up to receive requests on this ngrok domain and send them to my local host. And this is just for me to kind of tunnel my local host, which is protected from outside, which is not exposed to the internet, whereas this ngrok endpoint is. So the server can actually access that. You could also just have your own internet accessible server or use like a post bin or stuff like that to get these requests. But fine. Okay, so we have that URL. Now, I'm going to make a new SVG, and this one is going to have a script tag once again. I'm going to create a new image, and I'm going to set the source of that image to my domain here. So if the server is going to access this, if it wants to view that image, it has to get it from my domain, and I will see that it requested that. So I'm going to upload this image to the web, upload the SVG, and I'm going to copy its name, because this is the moment where we can find out if our HTTP request smuggling actually worked, right? Because we only get the output from this login. We don't get any output from this post request, but we think it's being executed on the backend. Now, if it is being executed on the backend, then we should get a callback in a bit. So let's try that out. Send this. We get a response back. Let's go to our terminal, and we see that we get a GET request to visited, saying visited is true. So the server actually did visit this endpoint, which is just amazing. We got an actual visit by the local host. So this means that we are so close to solving this challenge, because let's have a look at the final payload that solves this challenge. This is it. Again, very simple, SVG with a script tag. But the main thing that we do is perform this fetch request. This fetch request is a fetch to the local host on port 5984, which is where that CouchDB database lives. We then go in the users table, the admin, we get the admin data. We obviously also send the basic authentication token. So here, basic and an admin, you wouldn't download a couch. We make that request, and if we get a response, we then create a new image and set the source of our image to our endpoint again with the response, the verification document ready for us. So we will get a call back with the get parameter flag that has the flag of this challenge as the result here. I went over this payload a bit quicker because I've already spent a lot of time on this video, but you should be able to figure this out how this works on your own. And if not, be sure to hit me up later, send me a message, a DM or something, and I can explain it. But the moment of truth, let's see if this actually works. So I am going to go here, upload this exploit, copy the name, go to burp, paste in the name and make the request. And now let's check my listener, and we get something back. This looks a lot like a flag. Let's quickly check if this is the actual flag. So if I make this bigger and I do decode URI and then of this flag, and we see that the flag is hack the box. I downloaded some couch, and that is how we finally solved this challenge. And that is all that I wanted to show you guys today. I hope you enjoyed this write-up. If you have, then I also have my own YouTube channel, PinkDraconian, so go subscribe over there and follow me on Twitter. That would be greatly appreciated. And without further ado, I'll leave you guys to it. Have a lovely day, everybody.